Welcome to the third part of this series about Python object-oriented programming. It's time for your first class, so we will write together a class and see what it contains and how it behaves. So we will learn how to create new types in Python. Let's go! What you see here in my Python notebook is your first class. It's the way we define a new type in Python. You will find this file in the repository, so feel free to follow in your own Python notebook. As you can see, a class is defined by the keyword class, followed by a name and colon. Inside the class, there are functions. As we said, these are called methods. Aside from the fact that we call them methods, they are not different from functions. There is actually a small difference, which is that methods in an object have to accept a specific first argument, which is called self. As you can see, there is a function with a strange name that is underscore underscore init underscore underscore. To avoid saying underscore so many times, we usually call it dunder. So that is dunder init, there is open, and there is close. So what is a class? A class is the definition of a type. As we said, is the definition of a behavior. This class says that whatever belongs to the type lift has an open and a close actions that can be triggered. There is an initialization function somehow, and there is data. As you can see in the dunder init function, there is something called the self floor and self status. So let's see how this works. If you remember, we had an example with a duck at the beginning of this series. When we discussed the duck, we said that the type of that animal was duck. So the type is the idea, is the description of a behavior, but then there is a concrete object, which is the duck that you have in front of you, and there might be many. Each of them is a different object. In object-oriented programming lingo, we call the type class and the concrete object instance. So when you create a concrete object from a class, you instantiate the class. And this is exactly what we are doing here. Lift1 is a variable, and it contains one instance of lift. As you see, I say lift, open parenthesis, then I pass some values. Whenever you call a class, you are instantiating it. You are trying to create a concrete object that has that type. In this case, I am passing two values, one and closed. And these values are behind the scenes being passed to the init function. So the init function receives self, which is the instance that we are creating. This is automatically managed by Python. Then it receives an argument f, which is in this case 1, and an attribute s, which in this case is the string closed. Internally, Python assigns the value f to self floor and the value s to self status. So at this point, somewhere inside the lift1 object, there are two values, floor and status. Floor has the value 1 and status has the value closed. As we did for the internal types, for the types that Python provides out of the box, we can use the function type. And the function type run on lift returns main lift dunder main. Leave aside main for the time being and focus on lift. The class that we defined and that we instantiated is the type of our variable. Since objects have been created to contain functions and data, the dotted notation that we introduced in the previous lesson is still valid, so we can access the attributes of an object with the dotted notation. Namely, we can run lift1.floor and lift1.status. The first one returns 1 and the second one returns closed. As you can see, the values 1 and closed that we passed to the init function have been stored inside the instance and they are still accessible. Again, since objects have been created to contain data and functions, we can call the functions, we can call the methods of this object. In this case, I call lift1.open. I have to include the two parentheses because this is a function. But I don't have to pass anything for self because this is automatically managed by Python, as happened when we instantiated the class. Self in this case is lift1, so this is automatically passed by Python to the object. And what the function or the method does inside is to say self.status is now open. So if we run lift1.open, what happens is that lift1.status should change. And as you can see, while lift1floor is still 1, lift1status is now open, because the open function, the open method, changed something inside the object itself. So now we realize what we want. We have a structure that contains data and functions, and these functions operate on the type itself because the open method belongs to the lift object. As we did in the previous section, we have some exercises. These allow you to test if you understood what was said during the lesson, and actually they push a bit the boundary of what we said. They try to make you think about what was said. As I did before, I'm gonna read the exercises, try to explain them a bit, and then I'm gonna provide a solution, so you can pause the video between the explanation and the solution to see if you can solve them. So, the first exercise is create a security lift class that has the floor, status, and locked attributes. So this is a new class, it's not the lift class, it's another class called security lift, and this has to contain 3 attributes: floor, status, and locked, while the lift class we wrote before contained only 2 attributes, namely floor and status. The second exercise is create a closed lift class that has a default status of closed. The lift class had no default status, so you had to specify it whenever you instantiated it. The idea is to see if you can provide a default status, so can you instantiate a closed lift without passing the status and getting by default a status of closed. Exercise number 3, create a toggle lift class that has a method toggle, which toggles the status of the lift between open and closed. So in this exercise you have to add a new method. We have open, we have close, and we need a new method called toggle. So exercise 1 says create a security lift class that has the locked attribute. What I did was to create a class that is more or less like the lift class. I basically copied it, but I modified the init function or method, adding an attribute in the prototype, so this accepts self, f, s, and l. Internally, inside the body of the method, self.locked becomes L. So when I instantiate a security lift, I cannot instantiate it anymore passing just two values like 1 and closed, for example, but I also have to pass a third argument, because you remember when you instantiate a class, Python automatically calls the dunder_init method, so this is just like actually calling the dunder_init method, so you have to pass all the attributes that Python requires, so all the attributes that do not have a default value. And speaking of default values, exercise number 2 says create a closed lift class that has a default status of closed. This is very simple because, as I said, methods are functions, so whatever you learned about Python functions is still valid for methods. So here I have a class closed lift with a dunder_init method that accepts self, f, just like the lift class, but now s, the status value, has a default value, so s equal closed. This means that I can instantiate this class saying L equal closed lift of 1, open or 1, closed, but I can also instantiate it saying L equal closed lift of 1. At that point, self.status gets the default value of s because we didn't pass the value to the init function when we instantiated the class. The third exercise wants us to create a toggle lift class that has a toggle method, which toggles the status of the lift between open and closed. So this is again very simple because it's just a matter of adding a method under close. Actually, you can add it wherever you want. Usually we don't add methods above dunder_init because this is the initialization. It should be the first one, but it's just for clarity's sake. Python is not concerned about the order of the methods. Anyway, the toggle method does a very simple thing. Contains an if-else statement that says if self-status is open, now self-status is closed, else, which means if self-status is closed, self-status is open. So we learned how to create a class and we understood what self is, what dunder_init is, how to instantiate it, how to access attributes and call methods. In the next videos we will discuss a bit more the difference between the class and the instance and what relationship is there between the two. That's all for today. Thank you for watching.